10 formulas aren't given anywhere on your formula sheet. I do expect that you know how to find the slope of something. Ladies, I promise you this lesson isn't going to take super long. It's finding slopes of straight lines. You can do this. I have faith in you. And then you can get back to yelling at each other, trying to finish that assignment, or doing whatever you need to do. So, slope of a straight line is the change in the y over the change in x. The expectation is you know how to calculate slope. Good expectation, maybe bad expectation, not sure. So your slope formula is here. You need to know that. Live it, eat, sleep, breathe it. You need to know how to do an equation of straight line and linear function. So m being the slope, and what's b? Y-intercept. Oh. Kevin, did I teach you grade 10? Oh. Mr. Alice, I was totally going to take credit for that. Okay, some things we also know from grade 10. Parallel lines have the same slope, and perpendicular lines have the negative reciprocal. So if I have a slope of a line that's 2, let's say 2, the perpendicular slope is the reciprocal of 2, which would be 1/2. And if this is positive, this one's negative. You guys remember that from grade 10? No. Do you remember what perpendicular lines are? 2 lines that meet at what kind of angle? 90 degrees. Okay, so we got perpendicular, no problem. This is going to be super important to find the slope of straight lines on a tangent. And you're super excited. Okay. So some things you probably haven't remembered. We've done tangent lines in grade 9. If you were in Miss Steve's class, I think the whole is all on you. Because I think the rest of us maybe skip this. Circle geometry, we would have done tangents to a radius. It's okay. It's super easy stuff you're going to catch on really, really fast. Secant lines cross in 2 places. They touch the circumference in 2 places. And as you can see, they cut the circle. Okay? Or they cut the curve. These are called secant lines. Tangent lines are a straight line that lies so close to a curve, but it only touches in one exact place. So the things I said to my pre-calculated 11 class last semester, I said you can't find the slope of a curve. So I kind of lied to them, but they're not here, so let's not tell them. We're going to use tangent lines and a knowledge of straight lines to actually find slopes of curves. Okay, so I lied to them. Tangent lines only touch, it looks like it touches in more than one place. Like it looks like it touches in many places, but it really only touches at the point of tangency. So you need to know that. All right, this goes back to grade 9. This is what none of your grade 9 teachers taught you, but we probably should have. It only shows up in calculus. Okay, find the slope of a secant line. Nice and easy. How come secant lines are nice and easy to find the slope? You got 2 points. What do we have here? Very hard to find the slope only with 1 point. Secant lines, nice and easy. You got 2 points. You do your grade 10. Life's good. Bless you. Tangent lines, a little bit different because we only have that 1 point. But going back to grade 9, the tangent line is perpendicular to the circle's radius. That's really all you needed to know from grade 9 circle geometry. This is why we skipped it, and I figured you guys can. So if you have a radius, it's going to be any tangent line at a 90-degree angle. Easy peasy. That was a lot of stuff. Okay, the slope of a tangent at the point of tangency. Holy hell. So the line is called a tangent. The point of tangency is where it touches the circle. be estimated using a second point and the slope of the resulting secant line. All right, you with me so far here? So what I want you to notice is, let's look at some of these. So if I look at this line first, I have a point at A and I have a point at E. Those 2 points are very far apart. You guys agree with me? A and E, very far apart. So then I go A, because that's my point of tangency, A to D. Now I'm getting closer. And then my next points would be A to C. So A, the distance between your point of tangency and your second point is getting smaller and smaller and smaller. You guys have done this with limits, right? Isn't it that very first thing we did with the table? We keep getting closer and closer and closer, and we can estimate what the limits are. Same sort of thing here. So our last one would be A and B. So as they get closer and closer together, you're getting more accurate information. So let's do some math. See how good you are at your slopes. So the slope, what's the slope between A and E of that secant line? Change in Y over the change in X. So I'm going to have 8 minus 0 over 3 minus 1. So I've got 8 over 2. So my slope is 4. Right? And don't forget that your coordinate pairs have to stack on top of each other. Right? If you went 8 first, then that X has to go first. The coordinate pairs stack on top of each other. I'm going to say that because we have a hard time with that. All right, next one. So now I've got 5.25 minus 0 over 2.25 minus 1. So I've got 5.25 divided by 1.25. And that's going to give me, I do not, who is it? 1 point, sorry. I got oh, this was too big. I'm just going to start from the beginning. 5.25 minus 0 over 2.5 minus 1. So 5.25 over 1.5. And I get 3.5. I really don't like working in black. I think you guys can do the next one in your head. I'm going to challenge you to do it in your head. 3 minus 0 on the top. 2 minus 1 on the bottom. What's 3 divided by 1? Hopefully not 2. 3. And then for the last one, I did the math, and it's going to be 1.25 over 0.5. And that is going to be so let's talk about that. So we're using secant lines. I'm just going to scroll up for a second. We're using secant lines to find the slope of this parabola, so a curve, at a very specific point. This is your point of tangency. So you're using estimation. With me on this? So what do you anticipate the slope to be? You don't know. Do you think it's going to get closer? If I were to pick a point like A and B are still pretty far away, I could pick a point closer and closer and closer. Where do you think I'm going to end up at? Probably 2. So we would estimate that our slope is 2 using some secant lines. feel smarter now that we can actually find a girl can drink. All right. If we look at both on the left and the right hand side, we can identify what the slope of secant lines are. So pick a whole bunch of other points so that you don't have to waste your time doing it. And what they're saying the left and right hand side. So notice how we picked all kinds of points this way. So they're saying pick some points this way on the curve. Do some secant lines on this end of it instead of just this end. So moving right along, you can start seeing as we're approaching 1.75, 1.9, 1.99, where are we approaching? We're going to 2. And on this side, we're going to go away. 2. So our estimation from the other page was correct. That seems like a lot of work though, right? Table of values. All right. So we can do it using limits. Because I don't know what you guys, but I'm not sure how to do that table of values with 20 points or whatever to get a really accurate understanding. So I'm going to do some math and I'm going to do my limits. So we're going to find the limit of the slope. So m is just the slope. Not even do anything fancy, just got to switch. So let's put in the information that we know. We know that how we calculate the x value is just x, and if we were to do a table of values, and to calculate the y value, we would use the equation. That's all that means there, is it's your x-y relationship. So if I may give you a table of values, and I pick -2, you would substitute it into the equation x squared minus 1, right? Find your y. You guys know how to do this. All right. So we're going to do some math. So we have 2 points. We have our point of tangency, and we have the point that is made up from the equation. Pretty exciting stuff. So if I'm going to do the limit as x approaches 1, what's the formula for slope? y2 minus y1 over x2 minus x1. Right? That's just a slope formula. I didn't do anything magical. Now I'm going to fill in the information that I know. What's my y2? What's my second y value? X squared minus 1. Oh, I don't even know. X squared minus 1. And what's my first y value? 0. So I'm going to subtract 0 from it. All over, what's my second x value? X. And my first x value? 1. So I'm subtracting 1 from that. Oh, this is exciting. Anybody else really excited about this? So this is going to be, if I simplify as x approaches 1, then we're going to have x squared minus 1 over x minus 1. Is anybody excited about it now? There's some mathy stuff we can do. If we did direct substitution, I'd get indeterminate form, right? If I just did a direct substitution right now, I'd get 0 over 0. So I got to do some mathy stuff. So I'm going to have the limit as x approaches 1, x plus 1, x minus 1, all over x minus 1. So now if I do direct substitution, now, what's my limit approaching? 2. Sorry, that's not how I wanted to write it. values got us to the exact same place, but our knowledge of limits helped us do it much faster. Well, it was pretty fast when I gave you all the answers, but it helped us get there a lot faster. So what you would say is at the point of tangency, the slope is 2, not the slope of the entire curve. Does that make sense, everybody? Like at that exact point of 0, 1, 1, 0, 1, 0, that slope is 2. You can't make the assumption that somewhere else on that curve is going to be the same place. Make sense, everybody? Easy peasy. You can do this in your sleep because it's limits. Good practice for your quiz tomorrow.